Okay, on this video I'm going to go over how to write formulas for alkanes and how to name them. The first thing you need to know about are these prefixes. The number represents how many carbon are in your chain. So pent, just like pentagon, but pent tells us I have 5 carbon all connected together in a chain. Dec for 10, I have 10 carbons all connected together in one chain. So these are going to be the prefixes to tell me how long my chain of carbons are. The first worksheet is just over alkanes, and this means a chain of carbon that all have single bonds. So the suffix for all of these will end in ane. So if I have a chain of 4 carbons, that's bute, it's all single bonds, it ends in ane, that's butane, that's lighter fluid. If I have a chain of 3 carbons, my prefix is prop, it's all single bonds, so it ends in ane, so propane, just like in your barbecue grills. The next thing you need in this, for this first worksheet, branches, they end in YL. So if there's a branch off of our chain that has 1 carbon in it, we would call it methyl. If there are 2 carbons in a branch, we call that ethyl. If there are 3 carbons in a branch, we would call it propyl. That's usually as far as we have to go for branches. The next thing we will also need is part of our functional groups. And the only one we're going to use on the very first worksheet are these alkyl halides. So they're from group 17 on the periodic table. So fluorine, chlorine, bromine, iodine. If any of these 4 elements are attached to our chain of carbons, we will call them fluoro, chloro, bromo, iodo. That's why this O is here. It tells us we'll drop our I and E ending and add an O. Alright, so let's work some of the ones from our very first sheet. So I've already done the first one for you. Its name is propane. There are 3 carbons in our chain. Carbon has to have 4 bonds. So if this first carbon is only bonded to one other, we use hydrogen to fill in the other 4 places. Here on the second carbon, it's bonded once to this carbon on the left, once to the carbon on the right, so it only needs 2 hydrogen to fill in our 4 bonds. And then the last carbon, carbon 3, its only bond is to carbon 2. So it needs 3 more bonds. So we fill it in with 3 hydrogen. Drawing it out this way is called the complete structural formula. We can do a condensed formula, which is exactly what it sounds like. We take out all these little lines that represent our bonds, and we total up our hydrogen. So on carbon 1, it's 1 carbon and 3 hydrogen, so we write CH3. Then we have carbon 2, and it has 2 hydrogens, so we have CH2. And then carbon 3 has 3 hydrogens, so we write CH3. And then last, our molecular formula, we total them up. So there's 1, 2, 3 carbon, and then 3, 2, and 3 gives us 8 hydrogen. So that is our molecular formula. On the second row, I've given you the complete structural formula, and from that we need to name it. All we have is 1 straight chain of carbon. There are no branches, so this will be really easy. 1, 2, 3, 4, 5. So we look back on our sheet. The prefix for 5 is pent. These are all single bonds, so it ends in ane. So the name for this is pentane. It's all one word, no capital letters, it's not proper. So now we need to write a condensed formula. So on the first carbon I have 3 hydrogens, so that's CH3. The second carbon has 2 hydrogens. The third carbon has 2 hydrogens. The fourth carbon has 2 hydrogens. The fifth carbon has 3. So now I should add all of this up. Oh. C5H12. On the third row, it's a little bit different. we don't have just one row of carbons. We have carbons coming off. So these are called branches. What we need to do is we need to figure out what our longest chain of carbon is. Our chain of carbon can twist and turn. So if we just count from left to right, there's 1, 2, 3, 4, 5 carbon. What if this were carbon 1? We can go 1, 2, 3, 4, 5. So it doesn't matter now. 1, 2, 3, 4, 5, 6. Okay, so if we go like this in a stair step, this is my longest chain of carbon. So this is my chain. That makes this a branch and this a branch. So these two things are attached to the chain. So we draw a line through the chain, we circle our branches. When we name them, we name the branches first in alphabetical order. We tell what number those branches are located on, which number carbon, and then we name the chain. So go back to our prefixes here. In this branch, there are 2 carbon. 2 is eth, branches end in YL. So this is called ethyl. This branch only has 1 carbon, and the prefix for 1 is meth, branch is YL. So this one is called methyl. Now we have to figure out what carbon is it attached to. So if we start counting from the top, 1, 2, this one's attached to carbon 3. This one would be attached to carbon 4. If we count from the other way, 1, 2, 3, 4. So it doesn't matter which end we count from. One of them is going to be attached to carbon 3, and one of them is going to be attached to carbon 4. So it really doesn't matter which end we count from. So now we name it. Let's see, we said this one was carbon 3, this one's on carbon 4. So we list the branches alphabetically. Ethyl comes before methyl. So we're going to put 3 dash ethyl. We put dashes in between numbers and letters. We put commas in between numbers. Alright, now we need to list our next branch, methyl. It's attached to carbon 4. So dash 4 dash methyl. And then we name our chain. There are 6 in our chain. The prefix for 6 is hex. It's all single bonds, so it ends in ane. If I had enough room, this would all be one word. So 3 ethyl, 4 methyl, hexane. So now I need to draw it out. So every carbon has to have 4 bonds. So that means it really has to have 4 dashes coming off of it. And we fill those spots in with hydrogen. Alright, so now there's our complete structural formula. And then we need to do a molecular formula, so we need to count them up total. So I got 9. And then I got 20 hydrogen. So C9H20. Alright, let's do another one. It looks like this is my longest chain. There's 4 carbon. If I count this way, there's also 4 carbon. So we're going to keep it simple. We're going to choose the easiest chain. So that would be this way. So that's my chain. That means this is a branch and this is a branch. So if we look, this branch has 2 carbons in it. The prefix for 2 is F. It's a branch, so it ends in YL. So this is called ethyl. Spell it. Alright, this is iodine. So if we look over here, alkyl halides, it's one of those ones in group 17. So instead of iodine, I'm going to call it iodo. Iodo. Right, I'm going to list the branches alphabetically. I also have to include their number. So if I start counting from the left, this is carbon 2 and carbon 3. If I count from the right, it's still the same thing, 2 and 3. We want to use the lowest number combination as possible. So on this one, it doesn't really matter which way we start from. So E comes before I in the alphabet. So I'm going to say 3-ethyl, because we use dashes between numbers and letters. And then I'm going to say 2-iodo. 1, 2, 3, 4 carbon in our chain. The prefix is bute. That's a long U sound, not a short U sound. So this would become butane. So 3-ethyl 2-iodobutane. And then a condensed formula. So in our very first carbon we have 3 hydrogens, so CH3. Our second carbon has 1 hydrogen, and then we draw a branch off of it for our iodine. The third carbon has 1 hydrogen and 1 branch of CH2, CH3. And then our fourth carbon is CH3. We total it up now for molecular. 1, 2, 3, 4, 5, 6. 13 hydrogen and then an iodine. So we just tack our functional groups to the end. Okay, so those are 4 examples now. And I'll do one from the next sheet, or from the back side, I'm sorry. You're doing the same thing, but this time I've given you all the names, and you have to draw them out. And honestly, I think this is much easier than the other way. So this first one, 2,4-dimethylheptane. When we write out the names, we start with the branches. When we draw, we start with the chain. So I'm going to draw heptane first. So if we look, hept is 7. It ends in ane, so that's all single bonds. So I'm going to draw 7 carbon. I've included their bonds. And then it says 2,4-dimethyl. So 2 and 4 tell me I've got branches on carbon number 2 and carbon number 4. Di, right here, tells me I have 2 methyls. If I go back, methyl is 1. YL is a branch. So this means I have 1 carbon attached to carbon number 2, and I have 1 carbon attached to carbon number 4. Right, so that includes everything from the name. I need to go in and fill in my hydrogens. So here I only have 1 bond, so I need 3 more, and I fill it in with hydrogens. Here I have 3 bonds, I only need 4. Here I have 2. Here I have 3, and I need 1. I need 2 bonds on this one, 2 bonds on the 6th one, and I need 3 more bonds on the 7th. Now I need to go back and put in hydrogens for my branches. So this carbon only has 1 bond right here. So we're going to put 3 more. And then this carbon also needs 3 more. So now this is my 2,4-dimethylheptane. So now do a condensed formula. We have CH3, CH, and it has a branch of CH3, CH2, CH, a branch of CH3, CH2, CH2, CH3. Our branches, it doesn't matter if they're on the top of the carbon or the bottom of the carbon. I could have drawn it either way. I could have had one up and one down. That doesn't really matter as long as you put it on the correct location for the carbon. And then our molecular formula, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And 20 hydrogen. So that's all there is to naming alkanes and writing formulas.